Hi, welcome to clickmyproject.com. Now we are going to study about RCDA, Recoverable Concealed Data Aggregation for Data Integrity in Wireless Sensor Network. Now our basic domain is wireless sensor networks. Wireless sensor network consists of large number of sensor nodes and few sync nodes. Sensor nodes monitor the environment, detect event of interest, produce data, and collaborate in forwarding the data towards a sync. Now let us start abstract of our project. Data aggregation scheme based on privacy homomorphism encryption have been proposed and investigated on wireless sensor networks. These data aggregation schemes provide better security compared with the traditional aggregation since cluster heads can directly aggregate the ciphertext without encryption. Consequently, transmission overhead is reduced. However, the base station only retrieves the aggregated result, not individual data, which causes two problems. First, the usage of aggregation function is constrained. Second, the base station cannot confirm data integrity and authenticity via attaching message digest or signatures to each sensing samples. In this paper, we attempt to overcome the above two drawbacks. In our design, the base station can recover all sensing data, even this data has been aggregated. The first work that provides both integrity and confidentiality in the aforementioned scenarios, while covering a wide range of aggregates and returning exact results. We initially present SIES, a scheme that solves exact sum queries through a combination of homomorphic encryption and secret key sharing. Subsequently, we show how to adapt SIES in order to support many other exact aggregate queries. Finally, we augment our scheme with a functionality that identifies malicious sensors, preventing denial of service attacks, and attribute robustness to the system. Our techniques are lightweight and induce very small bandwidth consumption. What is meant data aggregation? In this process of combining raw data from sensor nodes of the network, network processing is done on aggregator node as per required aggregation functions and forwarded to base station. Secure data aggregation has been two types. Aggregator node decrypts, perform aggregation, encrypts, and forward to the base station. Secure data aggregation and encrypted data. Aggregator node perform the aggregation and encrypted data without decrypting it and forward to the base station. Data flow diagram for data aggregation. We have to start in our project, then we have to go into network configuration. Network configuration is based upon sensor nodes, cluster head, and base station. Then we're going to data generated source 1, source 2, source 3, and source 4 in sensor nodes. After data generated, we have to raw data in every source nodes. Then that raw data we are going to encrypted data is based upon public and private keys. After encrypted data, aggregated in cluster head of source 1 and source 2. The same procedure is based upon source 3 and source 4 data aggregation in aggregator A3. That aggregator A1 and aggregator A3 data are going to base station for aggregator in A3. That aggregation process is going to send courier for base server. That base server get result and then send all source nodes to data. Next, to architecture diagram. Architecture diagram is based upon node creation, key distribution, and query distribution. This is based upon base server configurations. Then we have to go into hash computation and encipherment of our data. Then that enciphered data we have to cipher and digital signature. That cipher digital signature values aggregator in signature. That aggregated signature verify that data. Comparison of every nodes. Let us start demo for RCDA. Now our software requirement for IDE NetBeans 7.3.1, WAMP server for MySQL, then Java JDK 1.7. Now our project title is a new aggregation. We have 4 packages: one base server, CS1, CS2, CS3, then graph. First you have to run clusterhead.java. in ch1 package. Going to sensor node tab, enter port ID for sensor 1, connect, then going to run sensor1.java, enters IP address of sensor base cluster head, port ID is 12. This is IP address for cluster head, this is IP address for port ID for cluster head. Now connected, then same as connect to sensor node 2, connect, then going to run sensor2.java, enter IP address for cluster head, port ID S23, connect, then cluster head 1 connected to base server, so run base station package base server.java, cluster 1, cluster head 2, cluster head 3. So first now we have connected to cluster head 1, enter port ID is 13, click start button, going to cluster head 1, base station tab, enter IP address for base station 127.0.0.1, port ID is 13, start button, click. Now we have got base station cluster head 1, cluster head 1 EGC2 is a host name of system, this is IP address of the system, click key pairwise. Now cluster head 1, cluster head 1, sensor node is a cluster head 1, this is IP address of the system, key generation, session key creation, click back, then we have to create sensor node 1 key generation, session key, back, same as sensor node 2 key generation, session key, back. That created keys we have to send to cluster head and sensor 1 and sensor 2. So we have to go into key sharing tab, select cluster heads, then select sensor nodes, get key, send that specified key, send, going to cluster head, receive public key, click receive button to click send button, then we are going to cluster head 1 sensor 1 form, receive key, same as cluster head ch1 sensor node sn2, get keys, send, going to cluster head, receive key, then send it to sensor 2, going to sensor 2, receive key, same as same cluster head 1 sensor node is a ch1, get key, send, going to cluster head, receive key, send it to ch1, that ch1 data, public key, private key and prime values, going to sensor 1. Now we have to going to encrypt data. First I'm going to get data, that means data generator. This is raw data of our project. 80 have going to encrypted data, click encryption, this is encrypted data, encrypted data for 80, this is encrypted data for 0, key generator for digital signature, this is private key, this is public key, sign that messages for these datas, This is digital signature. Then send to cluster head tab, send to cluster head, going to cluster head, receive from sensors, sends SN1. This is encrypted data, this is digital signature value. Same as sensor 2, encryption tab, get data, encryption, key generator, digital signature. Then send to cluster head, going to cluster head, SN2. Then we have to data aggregation checking, that means verification of data aggregations. The two users are trustworthy users, that means data aggregation has been successfully retrieved. Then encryption of cluster get data, get data, encryption, key generator, digital signature. Then going to send it to base station tab, get cipher data. This is sensor 1, this is sensor 2, this is cluster get, this is cluster get signature values. I have to send it to base server, going to base server, REC cipher tab, click CH1 button. This is cluster 1 sent values. Aggregation, data aggregation verification, trustworthy user, data aggregation has been successful. Decipher, this is decrypted value 80, 78 and 73. Start performance graph. This performance analysis for average cluster hits and computation time. This is performance analysis for number of data aggregation between computation time. Next we have to see simulation for data aggregation. First you have to node creation.java and specify the number of nodes, node formation. We have to create 25 nodes in each x and y positions. Click next, extract nodes. This is every node and that x and y positions. Then calculate distance. Then we have to insert the cluster nodes. We have to create 3 cluster heads and node IDs. Click next, view that nodes. Next we have to randomly choose cluster head 1, 21 and 20. View, this is cluster head 1, cluster head 2 and cluster head 3. This is base station. We have to connecting base station. That's all. Thank you for watching this video.